All right, well, good morning, everyone. Welcome to day 2 of DevOps Days. So today what I'm going to be focusing on is how Fetch built an open source vendor-agnostic observability platform. But before I do that, I will introduce myself. So my name is Karthik Ashokan. I have been with Fetch for 2.5 years now, so it's been a while in Fetch time. I am based out of Milwaukee, Wisconsin, but working remotely. And this is literally all you need to know about me. I love dogs. These are my dogs. So the top left and the two top middle ones are the same dog. It's Aiden. And then we have Norman, who graduated from intermediate training class. And then the last picture on the right over here, that is actually our last foster that just found his home a few days ago. So we're kind of sad and happy at the same time. But Norman photobombed him as we were trying to take pictures. So it happens. That's what our day-to-day working in the Ashokan office is like. All right. Oops. So agenda. What do we want to talk about? So I'll do a really, really high overview of like what is Fetch Words. Like what are we? What do we have? And then why did we decide to build this observability platform? And then we'll dive a little bit into the open telemetry portion of that we're using, as well as the rest of the observability infrastructure, how we're monitoring the monitoring infrastructure, how we're deploying it, and then sort of where we are with our adoption within developers. So let's get right into it. All right. So there's no way I could have made this slide. This was from marketing. I just copy pasted it because it's beautiful and it sums up what we have really, really well. Basically, we're a mobile app that you can download Android, iOS, and you go shopping like you normally would, and then you just take a picture of your receipts. Take a picture, maybe you get certain brands, you get extra points, but you'll just get Fetch points, which are then redeemable for gift cards. So basically, you just add an extra step of taking a picture, and then all of a sudden you're getting free money. And there are some really awesome promotions that are always running. Like one of my favorite one was there was a Klondike, like the ice cream bar. If you bought one, you got the entire money worth points back, so you basically got it for free, which is really cool. So, and we're in all kinds of other verticals as well, restaurants and even retailers. So that's Fetch. All right, so why build it? So I'll start with a question. How many of you here use a vendored APM tool of some sort? Yeah, so like 99%. How many of you know how expensive it is? Yeah, okay, so like 100%. Got it. Yeah, that was the main reason why we had to sort of figure out what we want to do with our observability. So what we were running into was we had a certain bill we were aiming for with our previous vendor that we were using. And we were 4 times that cost monthly when that was the entire year's worth of bill. And that was due to the fact that we were growing so crazy fast. And developers just wanted to like trace everything. They wanted to put like device ID and user ID and like these super high cardinality labels on their metrics. And we had to tell them to stop, which was not good, right? Like developers want to be able to get this level of visibility. And even if they don't want to, they like having the option that they can if they want to, right? And as DevOps, we're always trying to enable them to do what they do better. So that was one of the big reasons why we started looking into building it ourselves. And then additionally, we also have the ability to sort of customize everything ourselves. Since we're building the whole platform, we can start doing Fetch-specific things in our collection of data, of telemetry, which is also important. Okay. So let's get into the nitty-gritty a little bit. It's still really high level, but so the vendor-agnostic portion all comes from open telemetry. So if you haven't heard of open telemetry, it's a relatively new CNCF project. It is incubating, and it's picking up steam like crazy. There are a lot of vendors that are backing it. AWS is backing it, like a lot of the APM vendors back it, and the open source community for it is gigantic. The number of features that keep coming out for it are daily, and it is pretty amazing all that it does. So with OpenTelemetry, what we basically have are these plug-and-play receivers and processors and exporters that require very minimal configuration, but allow us to collect telemetry data from anything that we want. So we can get it from AWS Elastic Beanstalk, ECS, EKS. Of course, these are AWS specific, but there is no limit. You can really do whatever you want. All of the receivers, processors, exporters are written in Go, so you can actually go and write your own if you wanted as well, and potentially contribute to open source. So this is the core of how we're driving our vendor agnosticism. So you're collecting these telemetry data with these receivers inside of your OpenTelemetry collector. You have processors that do processing of the data, and then you have your exporters, which is where the vendor-specific portion comes in. So let's say we were using vendor A for our tracing, and then we decided that vendor A doesn't work anymore, we want to use vendor B. Instead of having to go back and change in the code the client libraries and then change the agent that's running on your hosts, we're actually using OpenTelemetry's standards for the client, as well as an OpenTelemetry agent that's running on all the hosts. So all we actually have to do is further downstream where we have our observability infrastructure and we have the OpenTelemetry collectors, that's where we just change the exporter from vendor A to vendor B, and you're done. So it is not a month's worth of developer effort and time. It is hours to days maximum to change a vendor now. And at Fetch, we have changed our APM vendor like 4 times in the last 2 years. So it is inevitable that it's going to keep happening. So figured we might as well try to do something that'll help our life or make our lives easier. All right, so here's the architecture, the core architecture of what this looks like. I apologize if it's too small, but I'll try to talk through it as best as possible. But there are really 3 main core components to what our infrastructure is consisting of. We have the OpenTelemetry collector pods. We have our Jaeger collector pods. And then we have Elasticsearch and then Kibana. Kibana is mainly for us as DevOps in order to monitor our Elasticsearch instance. But then we also have a bunch of supporting infrastructure, which is not exactly optional. I mean, it can be, but it's the direction that Kubernetes is going. Oh, I probably should have mentioned. Our entire infrastructure is in Kubernetes. Sorry about that, I should have mentioned that. The way that Kubernetes is evolving with cloud is all of the in-tree controllers that are there now are being replaced by vendor-specific ones because they add more functionality. So the AWS load balancer controller is something that we use in order to create certain custom resources inside of our cluster that we can then create NLBs, ALBs in order to get our traffic through. The AWS EBS CSI driver, so this allows us to have dynamic volume provisioning as well as resizing and additional EBS level type of configurations that we need to be able to do. Metric server. So metric server allows for auto scaling to occur. So metric server exposes metrics that will enable Jaeger to look at like the CPU and the memory and be able to add additional pods to scale to traffic, and same with OTel and all of that. External secrets. External secrets enables us to pull secrets from a secret store, in our case AWS Secrets Manager, and pull it in a secure way and store it as secrets in our Kubernetes cluster without having to use like environment variables, which please don't use environment variables for your secrets, but it can happen, right? So, and then Prometheus. I skipped Prometheus on purpose because we are using Prometheus right now to monitor our cluster itself, and I will talk about that after. So the way that the infrastructure actually works is you have your OpenTelemetry agents running on your hosts. The agents are constantly listening on localhost 4317. 4317 is a specific OpenTelemetry OTLP protocol port that is reserved for that. It is constantly listening for telemetry data, logs, traces, and metrics. As it gets the data, it will go through an OTLP receiver and do batching. So it sends these telemetry data in batches to either the trace collector, log collector, or metric collector. And the reason we separated these collectors out was so we can scale them independently. We don't have as many metrics, or I should say, if we don't have as many logs, but we have a lot of traces, we can scale our trace pods to have a lot more horizontal scaling and not have to do it just because of logs, for example. Additionally, with the metrics collector, with Prometheus, it's time series databases, which means that data has to come in an order. It cannot be out of order, otherwise Prometheus will drop the data. And when we had tested it with multiple metric pods, we constantly had out of order samples. So data was constantly being dropped because any one of the pods can be collecting a specific metric, but a different value of it at a different timestamp, and then sending it, and it could be batching at a different rate or a different frequency, and then the data comes out of order, and then you start having gaps in your data. So we had to kind of limit it to a single collector and then just vertically scale it. A lot more memory, a lot more CPU. The other part of our infrastructure that we're kind of hosting ourselves is Jaeger. So Jaeger is an open source tracing platform. And we basically are having, we have our Jaeger collectors, and then we have Elasticsearch as our backend. So all of our traces and spans, all of that data is stored in Elasticsearch. We chose Elasticsearch because it's really performant, especially for unstructured data, with documents and all that good stuff. And then we have a Jaeger query. The Jaeger query is how you actually go to the Jaeger UI. That's what actually fetches the spans from Elasticsearch. All right. For the logs and for metrics, we are in a hybrid. So we're sort of in Grafana Cloud right now. And so we're leveraging Grafana Cloud's Loki product, I guess, the hosted Loki, I guess, and hosted Prometheus. That is how we're actually sending our logs also through, so that in Grafana, we have a single source of truth, so people aren't going and looking in AWS CloudWatch for logs and then having to go and look in Grafana for metrics and then the Jaeger UI for traces. It all is actually available in a single place. So you can go to Grafana, and you got your Jaeger traces coming through there, you have your logs coming, and you have your metrics. All right. Okay. How do we monitor the monitoring platform? So the first thing we realized immediately was we can't monitor it through itself, because if it goes down, then we don't have monitoring of it. So what we did instead was we decided to run Prometheus alongside in the cluster and leverage the service monitors, the node exporters, and then an Elasticsearch exporter to monitor our Jaeger pods, our OpenTelemetry pods, as well as the underlying EC2 instances or the nodes that comprise of an AWS EKS cluster. So this allows us to monitor the platform independent of the platform itself. So if OpenTelemetry goes down, we know. If Jaeger goes down, we know. If Elasticsearch is running out of memory, we know. We get notified, we can act on it very quickly. If we were to go through it and it went down, it would just be like, okay, something's wrong, but we don't know what because we lost our data, our telemetry. So that's why we decided to run Prometheus alongside it. All right. Okay. And then lastly, like we're DevOps. So how are we deploying this? I don't think anyone's going to go and try to run kubectl commands and Helm chart installs and then not necessarily know what's installed, and having to do manual things is kind of like not what we like to do as DevOps engineers. So we decided to use AWS Cloud Development Kit, or CDK, for a couple of reasons. So one was we wanted state management, and all of our current, existing deployment tooling that we had was based on Ansible, which is fantastic, but it has no state. So we decided to just sort of build from scratch in CDK to, one, learn it, and two, to just get that state management with CloudFormation that's available. All of the code is written in in TypeScript, which gives us linting. We have Prettier for formatting, and then Husky, so that just based off of when you're committing your messages or committing your code, it'll do the linting and formatting and then push all your code. So you don't have to wait for some sort of pipeline to run to tell you if your formatting was wrong or not the formatting that we're trying to enforce, so that other developers are kind of working on the same, you're not going from one module to another, which looks completely different. So all of the AWS infrastructure is built out via CDK. So this includes IAM things such as the roles, our service users, as well as the policies, and then our EKS portions as well. So the cluster, the node group, and then within the node group, what type of instances, what kind of scaling, and all of that good stuff. And then we also do the networking. So we have our VPC, the subnets, load balancers, target groups, security groups. All of these are being provisioned via CDK. And we actually abstracted this out away from doing it via Kubernetes so that we can avoid having infrastructure that doesn't need to be deleted based off of deleting Kubernetes manifests, such as a load balancer. A load balancer doesn't need to go away if you're going to be deleting your OTel pods in order to spin them back up later. You can just reuse that, especially if you CNAME it in another account the way we do it. It was another step you would have to follow. So this allows us to actually abstract out the physical portions into CDK, physical in terms of AWS, and then keep the virtual Kubernetes stuff separate as well. And then we're actually even doing our Kubernetes work in CDK. So this is including things like the Helm charts installations, the Kubernetes manifests, patches, and then also modifying our manifests on the fly based off of resource ARNs and IDs and whatnot that need to be inserted into our manifests on the fly. And then for the actual automation portion, we're using Bitbucket pipelines. So Bitbucket pipelines will kick off on a git push, and then it will do a CDK synth, which was basically like a build. It'll compile your the output of what the CDK CloudFormation templates are. It'll do a diff, so compared to what's actually deployed versus what's going to be deployed. This even gives us YAML level differences in our Kubernetes manifests, which is super nice. And then it will actually do the deployment. And in some of our production ones, we have a manual trigger just like as a sanity check. But our non-prod environments they're just automated. They will go straight to deployment. And then notify us in Slack so we know what's actually happening. Okay, so in terms of developer adoption, where are we? And also just like what kind of metrics are we collecting? What kind of data do we have? This was a very challenging portion. So at Fetch, we have a culture of, there are a couple of words that are taboo at Fetch. We don't use words like force, standard. We use words like suggest, recommend, maybe you should do this. And it makes our lives as DevOps engineers very complicated because developers have free reign to do what they want. And that allows them to move fast, which is a huge advantage, and it kind of outweighs our complexity. But it means we have to sort of maintain more. And so when it came to Jaeger and the observability platform we were building out, it wasn't like developers like, okay, how do I do this? It was like, yeah, that sounds like it'd be nice. I don't have time to do it. So either you do it for me or something along those lines. And so what we actually did was we baked in a lot of the OpenTelemetry agent installation as part of the existing deployment infrastructure that we have, so that it would just sort of, you create a new environment and you already have the OpenTelemetry portion working. There were still some code changes that developers would need to do, primarily for our Go services, that would enable us to get tracing working for the Go services. For Java, we were able to leverage the JVM. But within a few months, our production adoption, so the services that are in production, we have an over 75% service adoption, which might sound crazy to some people, but for us that's huge. Like I said, because each pack does what they want, and so being able to get to this level already is really awesome. And then the next few metrics are like how much data are we ingesting? So in terms of logs, we are ingesting about 55K logs per second. We're ingesting about 2,000 traces a second. We have very, very chatty services that do a lot of chatting. So we have 60K spans per second, even though there's only like 2K traces. And then we're collecting 6K metrics per second. And then the last one is the reason like that justified that the work we did makes sense. So we're seeing at least a 50% decrease compared to what our vendor cost is in how much we're spending in our AWS infrastructure costs, which was pretty significant. Additionally, we're also scaled up at a level right now where we can handle almost double what you're seeing right now in terms of metrics. And we have the opportunity to scale it as we please, since we are managing the entire infrastructure ourselves. So what is next? Mikhail had sort of mentioned that it's not like DevOps is here and we're kind of done, right? It's a constantly evolving thing. Same with observability. You think you reach a point where you're finally observing everything and monitoring everything, and then you realize you're not even close. There's a new thing that came out, or you want this additional metric now that you hadn't thought of before. And so it's constantly evolving. So with what's next for us in our observability platform is it's up to us. It's not up to a vendor anymore because we are doing it ourselves. And we have all open source tools that have open source communities that are always thinking of new things that they want that they're contributing. And we're working on things that we can try to contribute back. So some of those things are getting tracing across AWS resources. We are 100% in AWS, but we are not just like Elastic Beanstalk or just ECS or just code in that sense. We are also in like Lambdas, and we want to be able to trace a service call that may have posted to an SNS topic that triggered a Lambda function. So we are working on figuring out how we can get tracing across those. And then collecting red metrics, or requests, errors, and durations on 100% of our spans. We have a sampling strategy for traces where we're sampling at a certain rate, but what that means is we don't get 100% of our requests, error, and durations. So we're working on building a custom processor that'll fit into the open telemetry environment thing that'll allow us to actually extract requests, errors, and durations across 100% of our traces. And then SRE is working in tandem with us, and we're working on getting Grafana, Loki, Prometheus all in-house. So we will truly be in a state where we're managing our entire observability infrastructure. And then one other huge advantage of bringing Grafana in-house is we can start connecting to like the Elasticsearch database, for example, directly, because right now we don't expose it because of security reasons and latencies and all of that. But if you bring in Grafana and Loki and Prometheus all into the cluster that you're running the rest of your observability infrastructure, you have a direct internal link now. You're all in the same VPC, you're all in the same network. And it allows us to do additional queries like what services are sending the most traffic? What endpoints are hitting the most traffic? Do we need to adjust our sampling strategies, either up or down? So we get a lot of other advantages there. And then, as Tony Stark says, just think of the possibilities, right? Like we are using open telemetry. There's new things coming out daily, new features weekly. It is just exploding, and vendors are on board, and there's just like, there's no limit to what we can do, which is really, really cool. So that's actually all I have. So
give a big hand. Karthik, thank you so much. You know, it's interesting how Leslie was talking about, developer adoption, and here you guys have implemented it. And I have to say that is an incredibly well thought out system, and most companies can't even match, half of that. So amazing job, Fetch guys. Very cool. Thank you very much.